is developed by Google. It's maintained by Google as well. So, like in India, all enterprises are running on Angular. So in India, Angular is quite popular, and Vue.js is also a great library which is getting some good traction in today's world. So let's talk about how the how you make things performant. So to answer that, I would like to introduce a new case study which I found. You can also Google that out. So if you have seen, like, there is a software called AutoCAD which is made for computer aided design, like you can draw buildings, cars, everything. So it was a long back when they want to port the AutoCAD to the web. So it's not possible because the code was written in C++ and it was all like graphic related thing. So here comes the WebAssembly. It's a great trending technology. It's been there, it's stable. So what it does is, like, it helps you to migrate all your code, C++ code, and run on the browser. So without losing any performance, you can run WebAssembly code anywhere. So the one of the greatest tool which is using that as well is the Figma. If you are familiar with Figma, which is used to for graphic designing, UI UX, it works on WebAssembly. So how the modern front end looks like, it should be performant. It has a huge ecosystem, like all the three which I mentioned: React, Angular, and Vue. Are all of them are huge in ecosystem. You find hundreds of thousands of libraries out there to help you out with that. And what it provides, it provides an abstraction. So at the end of the day, you will be compiling everything to HTML, CSS, and JavaScript, but you won't write that explicitly. You write in the form which all these frameworks provide, and it all at then compiles to the HTML, CSS, JavaScript. Then there is a huge community which I mentioned. Like, if you're stuck anywhere, you can just go to the Discord channel, Slack channels, and ask them, like, okay, like, I'm getting this error, how I fix that. So they will help you. So the community plays a great role, and they are scalable. Like, the React is used in production by Facebook, so they are handling like millions of users daily. So it's helping a lot. So now let's talk about the second part of it, that is the back end. So the front end which we saw, but to make that thing possible, we use back end. So what yeah so what backend does is, like, you have a lot of things working in harmony. Like, you have the server, you have the database, you have the cache, you have the load balancer, you have multiple servers. So let's talk about what server is. So server is just nothing, it just handles the business logic which you are writing. So when you log in, it goes to the server, and then server takes care of that. The database, so the database is nothing but like a storage thing. You can store anything, like your users data. So if I hit like button on any of the post, it just stores in the database, and when someone asks for it, how many likes it just gives you the count. So in just short term, it's how the database works. Caching is quite a like a very hard task to make, because, like, cache invalidation is there. So caching does nothing. Like, if you post something on Facebook or Instagram, so that image is just cached in the server. So if there are lots of users who are asking for this image in India, so it does nothing but they store the image in India instead. And if someone asks in US, so they have cache, like CDN network everywhere, and they store the image there. So the load balancers are nothing, they are just handling the load. So if the load gets increases, they will spawn new servers. Like, if they are machines running, but they are not handling the traffic, so they will just spawn new servers. And the cloud, which is the new term which we will talk about later. Yeah. So how the modern backend looks like, okay, I have talked about server, but, like, you won't be installing server in the physically in your home or in the company. So nowadays everything works on the cloud. So there are three major players who are just controlling the entire public cloud. One is the GCP, which is by Google, and the another one is AWS. And the the one of the greatest cloud, which is Microsoft Azure. So both all the three clouds are like quite great. You can do anything on that, but it takes a lot of things in terms of configuration to get up and running. So now there comes the new era of cloud that is fully managed. So there is a player called Heroku and Render. So what they does, if you have a application, you just pointed that, okay, here's my application code, and they will deploy it in one click. So you don't have to manage anything. It will be scaled automatically. It will be like if you have databases, it will be scaled automatically. If you have front end code, it will be shipped to all the CDNs. So if the user is in India, so the server will be nearest to him, so you get the best performance ever. So how it's helping us? So the cloud is hassle free. So like if you have seen, like you have hundreds of server, and the back in the days when you have to physically just plug things to the internet, it takes a lot of time and efforts to maintain that. So the cloud brings you hassle free, like you don't have to take care of that, no commitments at all. And security is the main concern in today's world. Like we have the power of the internet, but it must be secure so you don't leak any confidential data. So cloud comes with a great security at the base level. Like you don't need to configure anything. It will be secure out of the box, and it's cheap because if you go out and buy physical servers, it costs a lot, but in the cloud you are paying how much for what you use, so there is no commitment you are making in terms of buying the hardware. And flexibility, of course, like if you want a particular type of machine, you can spawn it, and if you want to upgrade it, you just change your plan to a different machine. So the plans are very flexible, and you can scale your application in a quite flexible way. And the mobility, like which I mentioned, like the internet is connecting the each and every person in the world. So if your users are in USA and your server is in, like, say, India, so if they communicate with your server in India, it will be a huge time in terms of latency. So you'll be getting a huge latency for that communication. So the cloud, all the three major clouds are having their servers in each and every country, each and every continent. So the application is served from the nearest possible location. So if I'm in India, I will ping it and it will be served from Mumbai or Chennai, wherever the server is. So that comes with a huge advantage of using the cloud. And apart from that, the clouds nowadays are coming with the GPUs and SSDs. So in today's, like, having SSD creates like a huge difference in terms of performance. And having GPUs, like you can put your machine learning model on that, let it run in the cloud. Once it gets trained, then you can just use it anywhere. So that comes with a lot of advantages, and it's quite cheap. So nowadays the cloud is in the mainstream, and you can deploy application in just a click of a button. So now let's talk about the app development. So uh, in app development, there are two phases. One is the native app, which is like the stable and recommended way by the platform. So you have the two main players, like that is Android and iOS in the mobile ecosystem. So the native app development, like you develop an app for a particular operating system, that is Android. So you will be using Kotlin for that. You will be using Java for that. So why you develop native apps? Because like they are stable out of the box, they are officially supported, they have the proper documentation. Like you can do a particular thing in a recommended way, they're always a recommended way for doing a thing. And for the iOS, you will be using Swift and Objective-C. But like building an app, for, say, you want to build an app, you are a startup, and you want to ship your app in a month, so you have to do the same thing. Like you have to write the code for Android, you have to write the code for iOS, and it will take a lot of time. And you have the to be you must have both developers, because a person writing Android, he's using Java, and the person writing iOS, it's Swift. So both the languages are different, both the platforms are different. So it is a quite time consuming process, and so the most of the startups are preferring the hybrid app development. So it's kind of a bleeding edge. It's you can't achieve everything which is whichever is possible in the native app, but it works out of the box and it's quite stable. So the idea of hybrid app is like you write once, so you will be having a single code base, and there is some bridges and there's some huge magic layer which you call, which will help you to run both the apps in Android and as well as iOS. So there are two popular frameworks out there. One is the React Native, which is is still developed by Facebook, as we discussed earlier in the web section. So you have React JS. So React Native is just an extension of that. So you will be having the same advantages of using the React, but it will work in both Android as well as iOS. Similarly, the Flutter, it is developed by Google, and it's quite trending right now. And you can build like performance app for Android as well as iOS. So it's kind of similar to what is achievable using React Native, but if you want to build a Flutter app, you have to use a specific programming language called Dart. So this is all about app development. Now let's talk about the infrastructure. So we talked about app, we talked about web, but at the back end, you must maintain the like the services running, the machines running, so that both the app and web works perfectly. So here comes the infrastructure engineering. So the infrastructure engineering is just the guys, if you are doing that. So there's an infra guy in all the companies, or you there is a specific role in site reliability engineer in companies nowadays. So the task of that person is to make sure that everything works perfectly. So the Google is working at a huge scale, but there is an infra team who is working to make sure that okay, how the deployments works in one click. So as I mentioned earlier, like the cloud, how it works, like in the back they have written all the layers, like okay, if you deploy your app, it will be working in a specific way, how the machines get allocated. So that comes under the infrastructure engineering. So if you want to do that, you must know like what networking is, distributed computing is, databases, logging, and if anything breaks, you must know how to fix it. So it's a great field, and if you are interested in, you can always pursue that. So the tools and technologies which comes under this particular infrastructure engineering domain are Docker and Kubernetes. So what Docker does is like if you have a particular code, so let's say you have a C++ code, and if you want to run it, you must have a compiler installed. You must have those dependencies or other libraries you are using. You must be installed in order to make that thing work. So what Docker does is like it has a particular configuration. So it just does all that things in a specific manner, which is written in the is configuration file, and it runs that thing by mimicking the exact environment which you return in. So what is this, like if I'm giving you a Docker file and the project, and if you run it in Windows, if you run it in Linux, if you run it in a server, it will work the same way as it is working all the three devices. So that's the great thing which comes with Docker. Kubernetes is a different kind of a system which is it will manage all your services running, and it will kind of a load balance everything. So for example, if you are having an application, so let's say Facebook has a backend, so it won't be running as a single instance. There are hundreds of thousands of machines running that same application thousands of times. So how you manage that? So the Kubernetes is an open source project by Google. It was developed by Google back in days, and it's been open source. So it will automatically manage the application. And so manage means how, like if your application goes down, if a particular machine goes down, it will spawn a new machine. It will load balance it. So if you are having less number of traffic, so it will just turn off that machines and decrease the number of instances, so you won't be wasting resources and just making those machine up and running. So now let's talk about the Terraform, which is like all these things which we are using. So you must be configuring all the machines manually, but it's not possible if you are doing at scale. You won't be logging into the machine and like, okay, install this database, then configure this database. It's quite a hard job and it's quite a time consuming. So the Terraform, what is this is like you're writing infrastructure in terms of a code. So if I write that as configuration file, and if I give it to the Terraform, it will just automatically perform all those tasks and it will configure that thing. So infrastructure engineer is quite great, and but it's not as trendy as other domains are, because it kind of a back end kind of a job, but it's a great thing if you pursue that. So now let's talk about the data science. So this is quite like quite a trendy field, and lots of people are doing this nowadays. So data science is like, if you know, data is the new currency. Like the Google, YouTube, and everything, all those products are free, but at the end of the day, they are using your data and they are generating money out of that. So how that thing works, like if I have a data at large scale, I need something to analyze that. I need some analytics out of that. So that's comes the data science. So the as a data scientist, you will be like extracting data. So if I am clicking on a post of, let's say I'm clicking on a cat picture on Facebook, and if I hit like, so that generating my data. So like, okay, so it's saying that I like cat pictures, so show this guy more cat pictures. So that's kind of a data extraction. So if I hit like, it gets logged in the fair servers, and okay, so that's part of a data extraction. Data processing is like you have a lot of data nowadays, and you must be process it and just segregate into what particular categories. And after doing extraction and pre-processing, you must be analyzing the data to get some inference out of it, and or some valuable output from that. And like, as I mentioned, the data is quite big, so there comes some big data technologies like Apache Spark and Hadoop, which are meant to handle lots of data, large stream of data. So the data is nowadays a quite a booming industry, and like it comes with a great opportunity. Now let's talk about the ML. Uh, just a disclaimer, I'm not the right person to talk about that because I have a very minimal knowledge, but I will try my best. So machine learning is a new field, like in India. Like nowadays, if you go to LinkedIn, everyone is doing machine learning. But it's been in the industry for since quite a long time. So machine learning is like don't you are doing something very intelligently. So to make the machine learn, you must have a data set. So the data set is the base of a machine learning. So you must be having a data set, and generating a good data set is quite hard. So generating a good data set is quite hard because the data set is the base of how your machine will learn. So the machine learning works on like a mathematical algorithms which just extracts features from the data and uh, generate models. So you will be generating data models out of those data set using some specific algorithms, and your model is ready. Now what, like if I have a model which says, okay, this is if I give it a picture, it says it's cat or a dog, but you must be deploying that model or integrating it into your product. As I mentioned earlier, if I click on a cat picture and I hit like, so that is my data. And if my model is ready with that, so if I hit the cat picture, it intelligently suggests me more cat pictures or give me ads regarding that or something. So that's how your model will be integrated into the product. So nowadays, if I open Facebook and I am having 5 friends and I see their post, and there is another guy who's friend with those same 5%, but you will always see that both the feed won't be same. It will be different because I my data is different. So like I like some concert pages or something. So you will see that all the feeds are different because like it's based upon your activity. So there is a huge amount of data which all these companies or all this social media platform are gathering, and they are using that data to target you and to give you intelligently suggest you what you will like. So the algorithm is trained for each and every user. So they are very good in terms of efficiency to suggest the right thing which you want. So that's all about machine learning. uh, Now let's talk about IoT. IoT is like a great field. Like you have seen Alexa devices which are connected to the internet and which are performing all those things. So same, it comes with a lot of things of working together to make that thing possible. The first thing is hardware, which you will be using. Like you have hardware which have some sensors or something to capture the data or something to interact with. So, and then comes the connectivity. Connectivity is nothing but an internet or intranet, whichever, like it helps to communicate with the other device or the server or anything. And the IoT devices must perform some actions. Like they either perform action or they can be a silently data capturing device as well. And they must be intelligent. So intelligent, what I mean from intelligence is like either they can perform something on given condition or circumstances. Like either they so nowadays like IoT device using machine learning to uh, take decisions locally on them without asking for the main server or supercomputer to what to do next. So they are quite intelligent devices nowadays. So what how you proceed with IoT is in today's world. So nowadays having a server is not possible. So you must be using some kind of a hosted server or cloud. So let's use the cloud for this system, and you will be using some kind of sensor, either that is a speaker, microphone, or anything like to talk with, to interact with, to gather some data. So in nowadays like it's quite booming in farm and agriculture industry. So they are installing those IoT devices which with specific sensors to gather the data. So they will be having cameras to capture the image of the leaves. If there are any disease, so it will notify the farmer regarding that, and it will also take some action. So it will be using the resources efficiently. Like if the plant doesn't need water, so it won't give it water, but if it needs, it will just turn on the pump. So that thing works automatically. So IoT is just integration of the all the technologies which we talked earlier. So IoT can be used as a data collection device as well. So in factories, when you have different machines working, so there are some smart Japanese machines using that. So if they gather a lot of data and they will process it, and if they have a particular machine learning model which tells them whether the machine is about to break or not. So if something is wrong, let's say the before breaking the machine RPM decreases by 10%. So and this thing happens. So there are a lot of like millions of data points. So they will take that, collect that data, process it, and it will notify them the machine is about to break, you need to repair this. So that's the integration of IoT plays a key role in today's world. So let's wrap up with IoT and let's talk about what's trending now. So the technologies change quite a lot. Like when I was in first year, my seniors were working on very different technologies, which I am working now, and you will be working on different technologies in like next 3 or 4 years. So the things change a lot, and uh, let's talk about what's trending now. So in today's world, like as I mentioned the JavaScript earlier for the web, TypeScript is playing a key role in today's like JavaScript development because it comes with static type checking. So it's a project by Microsoft, and you might be familiar with the code editor Visual Studio Code, which is developed by Microsoft, and it's written in TypeScript. So it's a great tool if you use like, but you must be knowing the fundamentals of JavaScript to use that. Now, another thing is Svelte.js, which is like the front end framework, and it's very, very, very performant, and it's comparable to what we discussed, like React Angular Vue. So it's the fourth player in that race. Now, on the right, you can see the two programming languages. One is Rust. It's been quite a while since the programming language is out, and it's developed by the Mozilla, the Firefox browser. So it's written to just where it's like around 5 to 7 years back, they want to just rewrite the entire browser engine because it was not as performant. So they developed a specific programming language, Rust. So you can compare it with C, C++. It's a low level language. It has some different programming paradigms, and it's trending nowadays. People are writing databases, people are writing low level drivers, networking drivers in Rust. And on the bottom right, you can see the Golang. It's the main programming language which is powering the backend servers at Google. It's the language which is meant to write concurrent things like performant concurrent servers. So it's great for multi-programming, and it's coming with a lot of advantages, and it's trending nowadays. So the all the Kubernetes and everything working in today's world. And if you are familiar with the trading platform Zerodha and everything, so Zerodha is processing millions of transactions in a day, and so the entire backend is powered by Go. So these are the couple of technologies which are trending nowadays. So I think that's it from my side. Thank you, guys. Yeah,
Great. Thank you very much,
yeah,
Panshu.
yeah.
Yeah,
If we have any questions, we can take, or like we can take it
yeah, I
afterwards
think
as
there
well.
are two on the chat box.
Okay. One is quantum computing backend or front end? So quantum computing is not like, we can't compare it with backend or front end. It's so your front end will runs on mobile or computer. It's a computer, and the backend which is running on a computer. So you can't compare those things. But quantum computing, as far as I know, it's different from the classical computing. Sure, your processors, it's different from those logic gates which are there on your CPU. It's using the qubits in terms of processing that. So I think they are it. You can't categorize the quantum computing in terms of front and back end, but it's a different kind of a computing device. So it won't be using any logic gates. So I hope this answers the question. Uh, all okay. Is there any difference between IoT and IIoT? I'm sorry, I'm not familiar with IIoT. Uh,
I think
uh,
IIoT, she refers to Industrial Internet of Things.
okay, yeah. So IoT is a broad field. So like industrial Internet of Things is comes under IoT, but like as I mentioned, the core of IoTs are just devices which are collecting data, which are performing actions. If something is, if either they are trained or they can ask for what to do next from the centralized server. So I think this answers the question as well. Yeah.
Great. Thank you. So, Adarsh, can we have you next?
Yeah, fine, fine. I'll
Yeah.
just share my
So,
screen.
our next speaker is Mr. Adarsh Naidu, and he's a GSOC 20 at Rocket Chat. He's also the DSC lead in his college, which is NIT Karnataka. So, please, let's have a session. It's a pleasure to have you here, sir.
Yeah, thanks. So is my screen visible?
Yeah, it's visible.
Okay, so hello everyone. Thanks for introduction. I'm Adarsh, a pre-final year from NITK. I recently completed my GSOC internship from Rocket Chat, and I thought, why not share my experience and help you guys crack GSOC as well. So this will be an early kickstart for you guys because GSOC is generally preparation for GSOC is generally started in the month of February. So I hope this presentation will help you in your journey for GSOC. And since the context is, open source, since Hacktoberfest is going on, one of the most important events and programs that drive open source is GSOC. So firstly, what is GSOC? It stands for Google Summer of Code, which is a globally run program run by Google. And what it does is it simply matches students with open source organizations. So you must be having some placement cells in your college. So this is a similar kind of thing, which where Google is acting as a placement cell, and globally all the students will act as the students, and then the organization will only be open source. So this will help the students by getting involved in open source community and getting familiar with all the processes which go on in open source. And this will also help the open source community by providing them a really smart, curated student who can get stuff done for their organization. So what's in it for you? What will you get by participating GSOC or cracking GSOC? Well, point 5 and 6, it summarizes almost everything. Firstly, you get a GSOC tag. GSOC is one of the most reputed internships that you can get, and it also pays a lot of money. So these are the two most important takeaways from GSOC. And then there are other things. You get to delve into open source, you get to contribute into open source. The code which you write, it gets shipped and deployed to the application which that open source is running. You learn in the process. So all of these are just consequences of taking part in GSOC. You learn to absorb the code. So in order to get selected for GSOC, you have to write a proposal. And that proposal should contain a detailed analysis of how you will be accomplishing the tasks which are required in your project. So in order to do that, you have to learn how to absorb the code which others have written. And this happens more than, I can say 99% of the times. You generally improve the code which is already present in the code base. Then you get to know your competition. Now, the number of people who participate or at least try for GSOC is a lot, is in terms of multiple tens of thousands. So when all of you guys will be competing for the same project in the same organization, you'll get to know a lot about how your competition is and where you stand. And then coming to the upgrade. So taking part in GSOC upgrades you as a whole, not only in your technical skills, that's one thing, but also your soft skills. Most of the times in GSOC, your organization will be based on some other country. Your mentors will be based on other country. You will be generally interacting with people who are from other country, and then you'll also have to learn the collaboration skills which are required to work in any of the open source organizations, because a lot of it happens in as a voluntarily and not much organized. So you get to learn a lot by taking part in GSOC. Now, why am I giving a talk in GSOC? We might have around 300 students in India who have cracked GSOC in this year. But the project which I did for GSOC is based on Alexa development. And I hope that most of you guys are already, although this presentation is aimed at general audience, whoever is interested in tech or any developer, but by the end of this presentation, I'll be telling you guys, I'll be telling especially the Alexa developers how you can get a GSOC project by taking part in it. Okay. So firstly, let's talk about the timeline and how GSOC actually works. So the first thing that happens is the mentoring open source organization apply to be a part of GSOC, and they apply to Google. And Google, among all the organizations which have applied, Google selects the organizations which they want to be a part of GSOC. And then these organizations announce projects. Now, these are the projects which they want students to take up. And then students submit proposals. Now, what is the proposal? So if your proposal is similar to resume, when you sit for placements, what you submit is a resume. But in GSOC, we call it a proposal. A proposal is a document which contains the entire details of how you will be implementing the project which that organization has announced, right? So at max, you can submit around 2 to 3. I think, yeah, you can submit 3 proposals at max, but it's always best to submit only one proposal. Okay, the next thing what happens is organizations request for slots. So we have multiple open source organizations in GSOC, and not all of these organizations will get to have the same number of students taking part in them. For example, Python, which is another organization which take parts in GSOC, it gets around 20 to 30 students. It gets around 20 to 30 slots, so it can take in those many number of students. But if you look at some other organizations, some new organizations such as 52 North, it gets only around 2 to 3 slots. So these are the slots which Google allots to these organizations. And the next thing that happens is, based on the number of slots available for the organization and based on how good the proposal is, students get selected based on that. So just to give you an example, in my organization which I applied for, which is Rocket Chat, around 86 students submitted their proposals, and out of that, the number of slots which Google allotted for Rocket Chat was only 8. So out of 86 students who applied, only 8 students got selected to work on those projects which Rocket Chat had in their list. After that is the coding phase. Now, coding phase is yet divided into 4 phases. Firstly, we have the community bonding period, and then we have phase 1, 2, 3, and then the post GSOC phase. I'll be talking about this later. And at the last, we have the results. After all the coding is done, after your code is tested, documented, deployed, and shipped, they look at your results, they check the results, they review your proposal. So in the proposal, you list out all the things that you have told the organization that you will do in this GSOC. So they review all of those accomplishments which you have told them that you'll do, and depending on that, they will sell they will announce if you have passed or not. So this is the last phase. Now, to look closely in the selection procedure, this is what happens. 40 days before the proposal submission deadline, organization will announce their project, and this is the time when all of you guys should be looking for the organization's page of GSOC, and exploring all of their projects to select one which you will be working on. Now, the ideally 30 days before the submission of before the deadline for submission of proposal, you guys should have already selected your projects, be it one or two. You must be firm that you will be working in this project. So that's what you should have completed 30 days before the deadline. And then comes contributing and interacting with the mentors. So, what do organizations select students based on? Well, the thing is, if you're able to prove to the organization and their mentors that you are actually worth spending a slot on, and if you can prove them that you have the potential to actually get that project done, actually complete that project, then that's a deciding criteria of if you'll get selected or not. So in order to do that, you have to continuously contribute even before getting selected. You have to keep contributing to their code base. You have to read their code. You have to contribute, and also you have to interact with the mentors. So every project will have two set of people, actually three set of entities. Firstly, the student, which is only one student per project, and then we have mentors. So these mentors will be from different regions in the world, and if you are stuck at any point, or if you need any guidance, these are the people who you should be reaching out to. So yeah, then you have to just contribute and interact with your mentors regularly. You have to maintain good relations with them, even that's necessary to get selected for GSOC. And at the end, selected students are announced. Now, these selected students are only those people who got selected to take part in GSOC, and not the end result, not the one who passed. Okay. Now, this is one of the most important part of GSOC, of taking part in GSOC. And if you're able to do this well, then almost 60% of your GSOC is done. So 60% of your GSOC, according to me, happens before you even get selected. That's that step is selecting a project. Now, again, there are two parts. You have to not only select a good project, but also select a good organization. So, firstly, coming to the organization, once this GSOC is announced and and the organization's announced, tens of thousands of students will rush to all of these organizations and their channels, interacting with the mentors. So, whatever the steps which I've listed over there, and it won't. So, tens of thousands of students will be doing the same thing. So you need to have an edge over them. For that, you have to select an organization in which there is less competition, firstly, and the organization which aligns with your skill set. For example, if you know web development, you have to choose an organization and a project which requires web development knowledge. And GSOC is not a place for you to learn something new. You that will almost never happen if you're trying to learn something new and then taking part in GSOC and selecting a project which which you're thinking of learning and then implementing. Then that's not going to happen, because there are a lot of people who already know that technology, and they will have an edge over you in the proposal, because they'll be able to clearly mention the steps in which they will accomplish the project. So firstly, you have to select an organization which has less competition and aligns with your skill set, and also an organization which is consistent. So it might happen sometimes that an organization which got selected for GSOC this year might not get selected for the next year. So you have to be careful and take that into consideration. So if we take Python, for example, that is selected for almost every year, but some other organizations such as NS3, they might drop the plan one year and then take up the next year. So you have to be careful before choosing that such organization. And after that, look for a project that aligns with your skill set. Yes. And then, yeah, check competition and their progress compared to yours. So once you select an organization and a project, what the first thing that you should be doing is go to their collaboration platform, right? I think it might be Slack or an IRC channel or a mailing list. Once you go there, you'll see that there are hundreds of students who are introducing themselves, who are already interacting with mentors, who have already selected their projects, who have already made some contributions to their projects. So you should not get intimidated by looking at some people who have already done something, because sometimes what happens is they only fix some minor bugs which even you could have done easily. So so what I would suggest is, just by do not get intimidated by looking at the competition. Also check their progress, if they have actually done something which is hard to do, or if they have just fixed a bug and then they're showing off, right? So I'll just quickly take you to the organization's page once again. So is this visible? Is a new tab visible? Can someone just confirm?
Yes, yes, yes.
Okay. Okay. So this is the archive of 2020. So if you see, there are around 200 organizations which got selected by Google to take part in GSOC. And here's what you have to do to select an organization. This is what I did to select an organization. I started from here, and I explored each and every one of these 200 organizations by just going to their profile page. And then over here, you can see the technologies that you used. So they have used PHP, JavaScript, Angular, and MySQL. If you know any of these, then what you should do is go to their projects, view projects, and then Okay, so if it is for next year, you'll have another option to view the projects which they want students to take up. So you have to go there, look at the projects, and then decide if you want to choose it or not. Let's say you don't know any of these, you have to go back. You have to look for the next organization. You have to again look at the technologies. If any of them fit your, if any of them aligns with your skill set, only then you have to, yeah, view the ideas list, and then depending on that, select the project. So, well, you won't at once find that perfect project which you think you can work on. You will have around 10 to 20 projects which you can shortlist from by exploring all of the organizations. Now, after shortlisting these 20 projects by exploring all the organizations, what you have to do is look at the number of people which they take. So this organization took 3 people, right? 3 people. So if around, let's say 30 people applied, then only 3 people got selected. So the competition is really high. Now, if you look at Python, for example, yep. Now, if you look at the number of people that Python selected, well, it's a lot. It's around 30. So this is a safe organization, right? This is a safe organization. If you know Python, well, the only technology used, which they use in the projects, is Python. If you know Python, and if you think you can contribute in the projects by going to their ideas list and reading the description of the task, then you should consider this task and not remove it from your shortlist, because there are a lot of people who which Python takes, and most of them are, yeah, well, most of them are Indians. um, Although that doesn't matter, but yeah. Now, yeah, this is to select the project. So if you have selected your project, that's around, a lot of the work is already done. The next step is, after selecting the project, is to absorb the code. After selecting an organization and a project, you have to go to their code base and start reading the code, fix minor bugs. And by minor, I mean, even if it's very less, even if it's just adding space to the documentation, or just fixing a console error. So that's something which you should be doing. By doing this, you will get some attention of the mentors. So if you start interacting, if you start posting your ideas in their collaboration channel, they will also go to your GitHub profile and look at your contributions, if you have actually done some contributions or not. So if you already have fixed some bugs and gone through the code, because even fixing these small bugs will require you to spend a lot of time reading their code. So they will get to know that you're actually committed towards contributing in this organization. Now, the next thing that you should be doing is, you should discuss improvements with your mentors in the project that you have selected. Then you should start pushing minor changes, which is based on your project. So your project will generally be a feature. Let's say they want some feature A to be implemented or to be improved. So that is one GSOC project. So you have to start pushing minor changes. Now, all of this is happening before even getting selected into GSOC. Now, that's a different story. And then you have to interact more with your mentors. You just have to show them, you have to, by interacting with the mentors, you have to prove them that you are eligible to take up this project, and that you can take up this project and you are eligible for that slot. And then you have to start contributing to the project. Okay. Now comes the most important part, which is writing a proposal. So this proposal is something which you submit 1 month before the results are announced, the actual results of all the people who are selected. And a lot of it will be based on your proposal. So to write a proposal, firstly, you have to understand the problem statement properly. You have to define the problem statement properly. You have to define your solution properly. And then you have to just write a rough prototype. If it is possible, it mostly won't be, but if it is possible to give a prototype, then the chances of you getting selected for GSOC will increase by a lot of folds if you're able to give a prototype, and then just put everything together and then write a proposal. So I'll be showing my proposal, the one which I submitted. One second, I'll just share my screen again. Okay. So this is the proposal which I've submitted to get selected into Rocket Chat. So it has 19 pages. So we just start with introduction, some background, some things which we did, some related works, and then coming to the contributions. So these were the contributions which I had already done before getting selected. So you can see that I already had one pull request merged, and a lot of important changes were already pushed in the project. This is what I had done before getting selected. So because of these contributions which I had already done before getting selected, they took my proposal more seriously and they had more confidence in me in order to give this project. After that comes the details, right? So all of the things which I've written over here, these are every component what I'll be improving in the project. So I list out one task, then I say how, then I've written how I'll do that. I've listed another task, and then there's description how I will do that, and then there are so and so on. I keep doing this. So you can see that this is really detailed. So they don't have any doubt over anything which I've proposed. So so some people, what they generally do is, even if they know a lot of things related to the project, what they do in the proposal is they'll just list out, okay, I'll do this, I'll do this, and I'll do this. But they forget to put more detail into how they will do it. And that is the most important part in giving confidence to the mentor that you are eligible for the project. Now that's exactly what I've done. I've listed out the task and I've written how I'll do it. The same thing over here. I've listed out the task. I've written how I'll do it for each, and this is a big description. You have to be as detailed as possible when listing out how you'll achieve those tasks. And at the last comes the timeline. So if you scroll down, so all of this has been my description of how I'll accomplish the task. And at the last comes the timeline, the detailed work plan. So in GSOC, we have 4 phases, which I talked about. So the first phase is the community bonding period. Now in community bonding period, you are supposed to, get all things together. You have to research a lot on whatever you have proposed. You have to keep all the code ready, which you're going to implement in the coming phases. If you think that you will run into any platform limitations or any roadblocks, you have to clear all of them during the community bonding period by interacting with the mentors, by researching on your own, and by experimenting and prototyping. So that's what you have to do in the community bonding period. And then comes phase 1 and phase 2. Phase 1 and phase 2 is when you do most of your coding to accomplish that project, to finish that project. This is where you do most of your coding. And coming to the payment, you can get out of GSOC at any of these phases. So in the proposal, we have this thing called timeline, right, which I mentioned. So in the timeline, I have mentioned that these are all the things which I will accomplish in the community bonding period. And in phase 1, I've mentioned that these are all the things which I will accomplish in phase 1. Now, if I'm not able to do this in phase 1, they have the right to remove me from GSOC. But if I'm able to finish all of these things which I've written in the proposal in the phase 1, that's when Google provides you with the first round of payment, which is around 30% of total. And this concludes your first phase. And then comes the second phase. The same thing happens in the second phase. Whatever you have written in your proposal, so whatever you've written in your proposal, you're supposed to do this that you're supposed to do that in phase 2. If you don't do that, the organization can remove you from GSOC. And after phase 2, you get another 30% of your payment. And then comes the phase 3. Phase 3 is where you wrap up everything. You document, you test, you deploy, you ask for reviews, you get everything checked, and this is when your final thing gets approved. Phase 3 is one of the most important phases, when you'll be working for more than 40 hours a week, depending on the project. And yeah, after phase 3, you'll get your remaining 40% of the payments, and this concludes your GSOC. And yeah, this will be the end of GSOC for you. Now coming back to the presentation. So this was about the proposal. Yeah, after getting selected, there are these 4 phases, and there's one phase called the post GSOC phase. So one of the most important guidelines which they have told in GSOC, this is without any consequence, is you have to keep in touch with the organization. Whatever code you have written, you should be responsible for that. You should work with the organization to fix any other errors that you face. And that's basically the post GSOC term. So there are no consequences if you are not able to do this, since your GSOC term is already over. But this is the spirit of open source. Now coming to my GSOC project, what did I work on? So the organization that I worked on is Rocket Chat. Now Rocket Chat is a collaboration platform, just like Slack and Microsoft Teams. So my work involved building and deploying an Alexa skill and Google action for Rocket Chat. So so what generally happens in Slack, we have different channels, and then we can send messages, and then someone might send a message to you, someone might tag you. So my the Alexa skill which I built, using that, users will be able to do this. They can just tell Alexa, what are my unread messages? Then Alexa will respond accordingly. And then you can also send messages. You can do a lot of other things. You can add leaders, you can create channels. So this was basically my project for GSOC. Now, if you're an Alexa developer, how can you get a GSOC project? Now, this is something that my mentor did. He's the one who started this GSOC project, and he was an Alexa developer. So in one of the slides, I had mentioned that there is, in the timeline, there is one phase where organization propose their projects. Well, in GSOC, there is another provision for the organizations. Students can actually propose their own tasks if they think it is valuable for the organization. So this is exactly what my mentor did. He proposed the Rocket Chat organization that what if you could have an Alexa skill through which users will be able to interact with their Rocket Chat account without having to log in and open the laptop. And the organization found the idea interesting, and then they selected the GSOC project. So if you're an Alexa developer and that's something that you're good at, what you can do is, when the organizations get released in the next year on around February, you can approach those organizations and propose them the same idea. You can tell them, so your software is pretty good. Would you like to have an Alexa skill built for your software, and will you be willing to take it up as a GSOC project? If they say yes, then again you have to write a proposal and submit to them. Depending on the proposal, you can, as an Alexa developer, get a GSOC project. So yeah, what should be your next steps to get into GSOC? Well, this is not really that early to get started with GSOC. People in my organization, which is Rocket Chat, a lot of people have already started going through the code base and contributing to the projects. So what you should do right now to get selected into GSOC is go to this website, which is GSOC Archives. Explore each and every organization. Look at their projects. Look at the projects which are still not completed. If you think you can take up that project, if you think you can work on that project, then you reach out to the mentors, start interacting with their community, start contributing to their code base. So when the GSOC next year, when it actually gets announced, you'll be in a whole different level compared to other students who started in the month of February. So yeah, so currently you can just go to that website and start exploring the organizations and projects. And yeah, if you have any questions, you can ask right now.
I think there was someone in the chat box asking for the link of the website which contained all the organizations for GSOC. All right, so thanks a lot, Adarsh, for such a great session. And if there are any questions, we are of course here to take them. And meanwhile, I'm sharing you guys 2 links, which are feedback and attendance sheet. I request all of you to fill those forms. And yeah, that's it. So for all the attendees, it is actually mandatory to fill these forms. So please go ahead and do that. Feedback is very important for us to make these kind of sessions even better. And once you're done with that, you may leave the meeting as well. And that brings us to the end of this session. Thanks a lot.